we're going to learn about monomers and polymers. Biochemistry is the chemistry of all living things. They're made out of 4 biomolecules. So every single organism on planet Earth is made out of 4 biomolecules: proteins, carbohydrates, nucleic acids, and lipids. Each biomolecule has building blocks. Think about the Lego pieces, the individual units. All right, so a building block of a protein would be an amino acid. Building block of a carbohydrate is glucose. Building block of a DNA or RNA, a nucleic acid, is nucleotide. And there's actually no true building block for a lipid or fat. Now, so for example, an amino acid is something called a monomer. Mono means one. Now, if I take a whole bunch of amino acids, many amino acids, I attach them together, I now have a polymer. So notice, I take many amino acids attached together, it's a polymer. Poly means many. So, monomer, 1. So I got 1 plus 1 plus 1 plus 1 plus 1 plus 1, and I attach them all together. Now I have a polymer. So that's how monomers and polymers are related. Polymers are made out of many monomers. You use monomers to build polymers. So, for proteins, amino acids, the monomer, they build polymers. For example, like enzymes, structural proteins in your skin and hair. There's a whole bunch of examples. The monomer of a carbohydrate is glucose, and you can build starch, glycogen from it. The monomer of a nucleic acid is something called a nucleotide. You attach a bunch of nucleotides together, you can build RNA and DNA. And lipids is kind of the oddball. There actually is no true monomer. You could say it's fatty acids, but it's not true, not realistic. And you could use those to build phospholipids and triglycerides. So how does it work to build? So for proteins, for example, we're going to do something called dehydration synthesis. Dehydration means we're taking away a water. We're going to make a water out of it. And synthesis is we're going to build it. So you notice at the top of the picture, right, I have 2 separate amino acids. And you see that red area, right, where the OH and the H on the other molecule, right, they're all highlighted. And if I would break the bonds and then attach those OH and the H, I'm going to form water. And you notice after that, we have a new peptide bond combining the 2 amino acids together. This is how I build a larger biomolecule, a polymer. Now, let's say you eat some food. All right, you're going to digest your food. And what you're going to do is you're going to do something called hydrolysis. Hydro means water, lysis is breaking. So we're going to take the water, break it apart, and we're going to break that peptide bond holding the 2 amino acids together. And you notice down below, now I have 2 separate amino acids. No atoms were created, no atoms were destroyed, right? I got the atoms to build those 2 new amino acids from that water molecule. The same concept happens with the other biomolecules also. So not only does proteins do dehydration synthesis and hydrolysis, so does carbohydrates. What I need you to really get down is the fact that you use this process to make the same biomolecule. For example, take glucose plus glucose together and you can build a disaccharide or beginning of a polymer, maltose. And as you can totally see, I'm still using the same carbohydrate biomolecule. I didn't change anything. So I could take the carbohydrate, right, the polymer, or in this example, the disaccharide, and I could break it apart and get glucose. Same concept with DNA, right, and nucleic acids. To make a DNA molecule, right, we're going to do dehydration synthesis. So we have the nucleotides on the left, right? I'm going to actually break off the phosphates. I'm not going to explain those today. That actually is what powers the reaction. But notice everything else is I'm going to break off 2 waters, right? And I'm going to combine the 3 nucleotides to form a nucleic acid. And of course, you can have DNA and you can break DNA, right? Same process, hydrolysis. Everything's going on is the same, right? So either I'm building and breaking using water molecules. Dehydration synthesis of lipids, same concept, right? So I have my H and my OH over here on the left, right? I'm going to break those, I'm going to chemically break those off, form of water on the right, and now all of a sudden the fatty acids attach to that glycerol, so we're in the process of building a fat molecule. And of course you can take fat molecules and break them off. Same concept, it's the opposite. Well, thank you for listening.